welcome back. In this lecture we are going to talk about, this is a continuation of the first lecture, and here we want to talk about the course instruction, guideline and resources, and for the course digital control of switch mode power converter. So, in this lecture I will first talk about what are the course component in this course. So, in this course we will have theory, we will have programming, we will have simulation and hardware implementation. Then we will also talk which part of this course will be included for assignment and final exam. For example, we will include theory and programming only, but hardware implementation is optional. I mean, it is not part of the assignment or exam. Then additional tutorial video will be given or provided in this course, which again is not for exam or assignment, but this is for further study, and hardware demonstration will be made using FPGA and microcontroller, as well as theory, programming and hardware resources. So, first thing, digital control in switch mode power converter, the course component. So, in this course we will have architecture part, which will include digital control architecture like a current mode control, voltage mode control architecture, digital architecture. Then we will have constant on time digital current mode control, constant off time digital current mode control, peak current mode fixed frequency digital control, and so on. So, there are various also digital pulse width modulation architecture. So, various architecture will be presented, and different modulation, like we will talk about trailing edge modulation, leading edge modulation, and what is the sampling technique under trailing edge modulation, what is the sampling technique under leading edge modulation, then how to sample under constant on time, how to sample under constant off time, how to sample under hysteresis control. So, all this will be discussed. Then we will talk about model development using MATLAB. So, we will develop MATLAB custom Simulink as well as the .m file, that means a custom interactive model development for this digitally controlled converter. Then in the theory we will talk about modeling technique, how to derive a model. There are different type of model, like a continuous time model. We will say whether the continuous time model can be used or extended for digital control or they are not sufficient. Then whether we need a more advanced model like a discrete time model, and we will talk extensively about discrete time model. Then we will show how this modeling technique, how far they can capture. For example, in our previous course in the control and tuning method, that course we have learned that this modeling technique, like a small signal modeling technique, if we get the linear transfer function model and obtain the step response, AC coupled response, and if we add the DC component, then we have compared with the actual switch simulation, and we saw that model reasonably captured the behavior up to 1/10 of the switching frequency, and beyond that actually the model is start diverging. But in this course we will show such model may not be even sufficient for digital control, even under low bandwidth also. So, we need to go for fully like a discrete time model, but such discrete time model may not be in terms of intuitive, like in terms of pole zero concept and how they are mapped into power stage parameter, which we can very easily visualize in continuous time model. So, here this such discrete time model, which will have lot of mathematical formula, matrix exponential, may not be so much you cannot visualize such pole zero or impedance effect, but it is very accurate. So, how to balance, how to design the controller using conceptual pole zero concept and how to slowly move into discrete time, we will also discuss. So, that means we want to utilize both our concept as well as accuracy, so that we can design as well as validate. So, that is the objective. Then we want to discuss programming. We want to learn, there are two type of hardware descriptive language, Verilog and VHDL. They are often used, but in this course we will talk about Verilog HDL programming, and we will develop from the scratch, that means from basic digital circuit, and then how such digital circuit can be extended to actually implement a full scale digital control. For example, a digital pulse width modulator, for example, we want to implement a digital PID controller, and I will also show what is the top down design method, so that if you want to implement an overall PID controller, how it can be broken down into pieces and actually implement different module and then create a main module to integrate this. So, this kind of flexibility will be discussed in detail. Then we will also talk about fixed point implementation and what are the steps for FPGA prototyping. Then in this implementation process, we will implement digital control extensively using FPGA and we will use Xilinx FPGA, but you can also use this Verilog code and you can use Altera or other FPGA devices. But apart from this, we will also present some demonstration using STM32 as well as C2000 series microcontroller. Okay. So, this microcontroller will be also discuss briefly how to program it, and then using those microcontroller, some case study of power converter will be demonstrated from the expert of this ST Microelectronics as well as Texas Instruments. Then hardware demonstration will be shown using buck and boost converter as well as for using FPGA devices extensively, as well as some case study of power factor corrector and LLC converter will be also shown using microcontroller. What are the interesting features in this course? So, this course is somewhat unique in the sense that this course will have a design and implementation, where whatever we learn in the theory we want to implement in the hardware, and there will be some additional tutorial video where we want to see if you get a transient response using your design model, MATLAB model, and you want to get the response, and then if you implement the same controller using an FPGA in a hardware, actual hardware, we want to show the response, how they are different, whether they are different or they are same, and because all practical thing may not be captured, and if they are not exactly identical, how far they are different and what are the cause of such difference. We will try to study some aspect, but this will be mostly for demonstration purpose, may not be in the part of exam. So, we will show Verilog HDL based FPGA prototyping and step for implementation, and we will be using buck and boost converter, and I have shown in the even in this lecture also I will show the picture of the test setup, and we will provide the schematic of our test kit, that means buck and boost for the power stage, and we will also provide the schematic and also layout file for the signal conditioning board, and we are using an off the shelf or the commercial FPGA kit, Xilinx FPGA. So, that also part number we will provide, so that if somebody is interested to actually validate, you can do it, but we will provide the information. But again, this hardware implementation is not part of the assessment in the exam. Okay. So, these files will be provided along with our Verilog HDL programming file. Then I will also show many digital control demonstration, using FPGA based demonstration anyway we will be showing extensively in this course, but apart from that, as I said, few design case study, let us say using PFC converter case study, here using STM32 microcontroller, the LLC controller case study will be shown. Similarly, we will show digital control case study using for PFC converter using C2000 series microcontroller, and Texas Instruments design expert will be demonstrating. In this course, we will be also showing how to use mixed signal oscilloscope, because we are also dealing with digital control. So, naturally our power converter, all signals are analog, like if you try to see the output voltage, inductor current waveform, gate signal, we use analog probe for the oscilloscope, right, to show. But at the same time, we want to also see some of the digital control signal, right. So, we need, or we want to test some of the, let us say, digital command signal. So, how to use, that means we need a mixed signal oscilloscope in which there will be dedicated analog channel as well as digital channel, and here you can see the digital current waveform or digital signal waveform in analog channel, but there is a penalty, that means it will unnecessarily slow down the some of the rising or the sharp edges, because in the analog probe basically you have to maintain linearity, as a result it has a bandwidth limit, but there are dedicated digital channels are there in the oscilloscope which are used to actually precisely show the digital control waveform, and such demonstration how to use mixed signal oscilloscope, what are the different functionality, that will be demonstrated by expert from Tektronix. Then this is a complete test setup where we have the signal conditioning board and below this signal conditioning board is a board to board connector is there, that we have a FPGA kit that is there, and this is the power stage board. So, from the power stage board you will measure the sense voltage as well as the current sensor, and those will be passed to the signal conditioning side, and the signal conditioning side will have A to D D to A converter as well as buffer circuit and other signal impedance matching network, and then finally it will go to the FPGA. Now, the course component for assignment and the final exam. So, it should be we should keep in mind in this course there will be a lot of demonstration which will be covered, but for the exam as well as for the assignment only the limited part which is the architecture will be covered completely as a part of assignment and the exam, where there will be various digital control architecture which will be covered in the class, the theoretical part, architecture and the circuit diagram, that should be part of assignment as well as exam. Similarly, different modulation and sampling method will be part of assessment for the exam as well as assignment. MATLAB simulation, although we are not going to for the exam we are not going to ask student to simulate live, but we may ask the student in the assignment that if they simulate a model which will be showing the how to develop the model, then we will be asking what is the steady state value, whether this gain you are getting stability issue. So, this is for cross checking, because this will help you that you should do MATLAB, the process will be shown extensively, but you should actually develop your own MATLAB file and run it, then only you can visualize the digital control, otherwise the learning will be incomplete. So, in the exam and the for the assignment purpose only, this will be only using in the assignment, where we may ask that if you simulate a let us say a digitally voltage mode control buck converter, and everything will be given in terms of power stage, we will provide you switching frequency, everything will be provided, then you have to check what will be the steady state waveform, what is the average inductor current and so on, what is the ripple parameters. Okay. And of course, the theory is very much in the part of exam as well as assignment, where we will be talking about lot of modeling technique, how to analyze, you may have to find some results of stability. Then we will ask some design case study, that means how to design a compensator digitally, and we will be covering this thing in detail. So, this will be part of exam. Also, we will be covering lot of in-depth Verilog HDL programming and for FPGA prototyping, but only Verilog programming will be part of exam and assessment. So, FPGA prototyping will not be asked, we are not going to ask you that you prototyping using FPGA, because we will show if you can have a Xilinx, even the verification of this code in this simulation, that we are not going to ask, but whether you are able to write a Verilog HDL code or not, that may be part of assignment or that may be some part of the exam, because we may ask some objective type question using this Verilog HDL coding. So, that means Verilog HDL programming will be taught in detail and some part will be actually part of the assignment and exam. Finally, we will provide step how to implement. For example, if you want to implement using FPGA, or even there will be some demonstration using C2000 series microcontroller or STM32 microcontroller, we may ask what are the steps, because those lecture will be part of the course. So, you may not be asked to actually implement that using either this microcontroller or FPGA, but you should know what are the summarized steps for implementation, so that step if you understand thoroughly, you prepare yourself, it may be helpful in future. So, that future not beyond this course you want to implement, you go to industry, or particularly this is useful for the industry practitioner, they may try to in their design. So, that is why these steps are important. Then in this course, what are not included in the assignment and exam? It is there in the course material as well as the lecture, but it will not be part of assignment and the exam, which will be hardware implementation. That means it is not mandatory. That means you do not need to implement hardware, you do not need to buy any power stage anything, you can just refer this course and you only need to do some kind of MATLAB. So, hardware implementation is not mandatory, but if there are some interested student who want to actually implement, we will provide you all the detailed documentation. Okay, so you may try out, but this is optional. Similarly, Verilog HDL simulation, how to use ISE simulator using Xilinx, this is not mandatory. That means you may not need to actually implement Xilinx ISE simulator. That means you may not need to install ISE simulation software, because sometimes it may not support different type of because whatever we will be using, if it does not support your computer, so we are not including this simulation, or you don't need to install the Xilinx ISE software for part of assignment and the final exam. But you need to know how the effective way of how to implement Verilog code. Okay, but we may provide you some open source software which can be used to check your HDL coding. It is not mandatory that you have to use Xilinx ISE for checking, because there are many other open source tools are available where you can check your HDL coding. So ultimately you have to learn Verilog HDL programming part of this course, but for simulation using ISE is not mandatory. Similarly, FPGA prototyping is not mandatory, that I have already mentioned. So you don't need to buy any hardware part just to get certificate for this course, but any interested student can do that and implement it. Then implementation using STM32 microcontroller, that will be demonstrated, but again it is not mandatory. You don't need to buy any software, you don't need to buy any STM32 microcontroller for getting this course certificate, as well as you don't need to buy C2000 series microcontroller. So these are part of demonstration for learning, but you need to know the step for implementation. And finally, simulation and hardware validation, we will be showing how to validate using MATLAB your design, that means your analytical model, the result obtained from the discrete time model, as well as your MATLAB simulation. We will show you validation, but that is not part of assignment and the exam. You don't need to validate and that will be not asked in the assignment. But hardware validation, you may try it out. That is also this part, it is not part of this course. So this will be shown just to get an idea that what will be deviation, can you really validate. So only for learning this process will be covered in this course. So in this course we will be showing lot of demonstration, and in this course apart from the regular lectures there will be some additional lecture, and which we call tutorial lecture. That means one will be lecture, that means whenever you will find lecture 1, lecture 2. So this like ... there will be multiple lecture and whatever. So this will be part of, these are the regular lecture. And we have already discussed in the regular lecture which will be covered in the assignment and the exam. But apart from this regular lecture, apart from this, we will also have some tutorial lectures. Like it will be numbered as tutorial 1, tutorial 2, like that ... But these are not part of, this is an optional video. So these are the optional videos, and it will not be part of, regular lectures. So these are the optional video tutorial lecture that will be also covered in this course. That means this will be maybe 1 week you may have some 2-3 this tutorial lecture, tutorial 1, tutorial 2, like this. But again those who are interested can go through this video, but for the regular class assessment these videos will not be considered. Okay. So in this course I just want to summarize what are the reference material that will be used. One is that our earlier course, NPTEL course, the control and tuning method in switch mode power converter. So this is already available in YouTube, and in this course, because this particular course is actually this course has discussed in detail different analog modulation control technique for analog control. So whenever we will start our digital control, we will refer some basic analog control as a starting point, and we will take it for granted that those basic analog controls are more or less known, but we will provide you the reference link, so that one can go in this some of this lecture of this course and get detail. So, this is one tutorial paper where one can get a summary of different modulation and control technique, but this is for analog control. So, for digital control some basic, this book is Fundamental of Power Electronics. In this book actually latter part of this book covers some starting of digital control. So, one can get some basic idea of digital control here, and this book Digital Control of High Frequency Switch Mode Power Converter may be useful for some advanced topic, but in this course I will primarily highlight majority of these topics in this course material. So, even if one does not go through all this material, but we will refer in particular lecture what concept we will be talking about, and their direct all the diagram that we will be providing, that should be more or less enough for this course assessment and understanding. But anything detail about the research topic, we will provide some research paper link, as well as anything related to some architecture and exploration of other converter topology. So, you can provide you some reference link, but this course material whatever we will be covering should be self sufficient for this course. So, with this I want to finish it here. Thank you very much.